In today's video, we are going to explore two important groups from the periodic table, the group 7 elements, known as the halogens, and the group 0 elements, referred to as the noble gases. We'll examine their key properties and the trends observed within each group. Beginning with the halogens, these elements are known for their hazardous nature in various forms. Fluorine is an extremely reactive, poisonous yellow gas, while chlorine, slightly less reactive, is a poisonous green gas. Bromine stands out as a reddish-brown volatile liquid and is also poisonous. Iodine, on the other hand, is a dark gray solid but can form poisonous purple vapors. However, despite its dangers, iodine is also an essential antiseptic that has saved countless lives in medical applications. As for the heavier halogens like astatine and tennessine, you can safely ignore them for now since they rarely appear in the course material and are not commonly encountered in practical scenarios. A unique feature of all halogens is that they exist naturally as diatomic molecules, meaning they form pairs of atoms. This diatomic structure is achieved by sharing electrons through covalent bonds, and this bonding pattern is consistent across all halogens. For example, two chlorine atoms form a Cl molecule by sharing electrons to complete their outer shells. Halogens are also capable of forming covalent bonds with other nonmetals such as hydrogen or carbon, leading to compounds like hydrogen fluoride or carbon tetrachloride. These are classified as simple molecular structures, and we delve deeper into covalent bonding and molecular structures in another video. Now, similar to the alkali metals in Group 1, the halogens in Group 7 also exhibit trends as you go down the group, but these trends occur in the opposite direction. For halogens, the melting and boiling points increase as you move down the group, while their chemical reactivity decreases. This decrease in reactivity is primarily due to the increasing distance between the outermost electron shell and the nucleus as the atoms get larger. Because the nucleus is positively charged and responsible for attracting incoming electrons, this increased distance weakens that attractive force, making it harder for larger halogens like iodine to gain an extra electron. As a result, iodine is less reactive than elements higher up in the group such as fluorine or chlorine. In terms of bonding, halogens commonly form ionic bonds with metals. When a halogen atom gains an extra electron to complete its outer shell, it forms a negatively charged ion known as a halide. The naming convention for halides involves changing the ending of the element's name to "ide", so fluorine becomes fluoride, chlorine becomes chloride, bromine becomes bromide, and iodine becomes iodide, all of which are halide ions. You'll most often encounter these halides in ionic compounds formed with Group 1 alkali metals, such as sodium chloride, but they can also bond ionically with metals from other groups. One of the most interesting and testable reactions involving halogens is the displacement reaction. In this type of reaction, a more reactive halogen can displace a less reactive halogen from its compound. For example, if chlorine gas is bubbled into a solution of potassium bromide, the more reactive chlorine atoms will displace the bromide ions and bond with potassium instead, forming potassium chloride. This works because chlorine is higher up in Group 7 and thus more reactive than bromine. The fundamental rule to remember is that a more reactive halogen will always displace a less reactive one from a compound. So fluorine, chlorine, and bromine can all displace iodine, since iodine is the least reactive among them. Now moving on to Group 0, the noble gases. While we had considered dedicating an entire video to them, the truth is that there isn't much complexity to their chemistry that you need to memorize. Noble gases include elements like helium, neon, argon, krypton, xenon, and radon. All of them exist naturally as colorless gases and are completely inert, meaning they do not normally react with other elements. This chemical inertness stems from their fully occupied outer electron shells, which makes them stable and uninterested in gaining or losing electrons. Because they don't form chemical bonds easily, they exist as single, isolated atoms rather than molecules. Another notable feature is that noble gases are non-flammable. They cannot catch fire or support combustion. Lastly, one trend that you should remember is that the boiling points of noble gases increase as you move down the group, which is similar to the trend seen in halogens. And that's essentially everything you need to know about halogens and noble gases. If you found this video helpful, please share it with your friends, give it a like, and subscribe for more content. We'll catch you in the next video.